there are 3 different basketball teams. Okay, each have played 5 games. You have the scores of each games. So for number 1, suppose you want to join one of the 3 basketball teams. You want to join the one that is doing the best so far. If you rank each team by their mean score, which team would you join? Stefan? Jaguars, good. Join the Jaguars. It has the highest average. Okay, highest average right now. Okay. And if you do not want to use the mean scores but want to use the median, which team would you now join? Mia? The Wolves, good. Okay, remember, mean is the average, the median is the middle once you put them in order. So pretend you're coach for the Lions, you're being interviewed about your team for the local newspaper. Would it be better for you to report the mean score or your median score? Emily? The mean, good. Because it was higher of the two. The mean was 68.2 as opposed to the median, which was 65. Okay? Any questions on this first situation? Okay. Right, the next situation was you and your friends are comparing the number of times you have been to the movies in the past year. Okay? By comparing the modes, which person went to the movies the least per month? Yep. Mary, good. Mary, she had a mode of 1. By comparing medians, which person went to the movies the most? What do we think? Liam? All the same. That is correct. All the same. Because what was all of their medians? 2. Good. Okay. Rank the friends in order of most movies seen to least movies seen by comparing their means. Who had the most? Camilla? Good. Good. John and Brian. And then we have Kelly. And then Mary. Good. Okay. Which month, by comparing the means of movies seen in each month, what was the most popular movie month? July is correct. Okay. Now, by comparing the medians, which month is the least popular month? Liam? January. Okay. So that last question, what is the mean of the medians? So what you had to do was take the medians of each month. Okay? The medians of each month. So we have January was 1, February was 2.5, March 1.5, 1.5, 3. Okay, so once you found the medians, you then take the average of those medians. And what do we get? Emily? 2.08. Okay, 2.08 was the average of the medians. Okay, so that last question, pay attention to the way it's being asked. Just like for the practice, some of those questions have been pulled from the SATs, so even though you know the content, the way the question is asked can be a little confusing. Okay, any questions on the warm-up? Okay, any questions on the 4.1 practice in your pink packet? Camilla? The median is the center, so the outlier will not affect it. It will still remain the center, most likely. If it's like 4,000, close to 4,800 is an extreme outlier, so the average is going to change drastically. However, the center of that data will roughly be the same. Because there's an outlier. 4,800. So if you're looking at what best describes this information, okay, if we remove the outlier, so if we remove 4,800, the mean and the median will roughly be the same. But if we keep the outlier, the mean will drastically change and not be an accurate description of the rest of the totals, okay? And the median will still remain, like, we'll give an more better accurate description of what they should choose, okay? So, like in that example, the mean was pretty much 1450, right? The median was 608, 607. So if we removed that 4,800, then the mean will now pretty much be close to 600. So when they're equal like that, either one can be used. But if there's an outlier, the median is the best choice. Okay. Any other questions on the practice? Yep. There will be a question on some of the practice to see the difference, so you guys can see the difference. If you're giving data like that, you won't be taking out the mean, the outlier, but you want to know the differences between. So if you're on the fence about if a number is an outlier or not, if you eliminate that number in question, and if the mean and median are roughly the same, then that's like, that will be determined your outlier. You know, because there's some that are not really extreme, so you're like, is it? Maybe. But if there's a difference between the mean and median with that specific outlier, then once you remove it, it ends up being the same. Okay? Any other questions? All right. If you take out your notes and turn to 4.2 in your white packet, the notes, that's the practice. This is on page 8. Okay. Now I will let you know there's a lot of information in here. Okay. This is a lot with visual representations of graphs, some detailed information about what we're looking for. Okay. So we are starting with visualizing a set of data for stat. Okay. So first thing we look at is something called the normal curve. Okay. The normal curve is symmetric and bell-shaped. Okay. It's symmetric and bell-shaped, which you see in the middle of the page. Okay. That is a normal curve. Okay. Typically, if it's approximately normal, the mean, median, and mode fall right in the center. Okay. So the mean and median and mode, typically mode you won't see, you would really see the mean on this normal curve, will be in the middle of the data. The two sides would be symmetrical. Okay, and then there's tails. Okay, the tails that flow out. So we're going to see curves that are not normal, okay, meaning to the one side or the other. But you always want to look for your normal curve because that's one more measure of dispersion, which is called standard deviation, okay? I mentioned this last time in terms of the range, but standard deviation measures the spread and the variability, okay? The spread and the variability. So think of your test scores, right? Okay, say the average is like an 88, but our standard deviation is 3. That means the majority of the class is within that 88 average, which is great. If we had a standard deviation, say of 13, that means there's a wide spread of grades. Okay, there's a wide spread of grades, which we don't want. Okay, standard deviation is the difference from the mean. Okay, we typically use standard deviation to describe the spread of the data and see what we're looking at. Okay, so we find this in our calculator, standard deviation. It has SX, which we'll get to in a little bit. Okay, this little piece here, small, you could just cross that out. We don't need to know that. Okay, standard deviations, when we create a normal curve, there's 3 standard deviations above and 3 standard deviations below. Okay, so what that looks like, and we're going to fill out a normal curve shortly. If you have a small standard deviation, okay, if you have a small standard deviation, if you notice the data is clustered to the middle, which is near the mean. This is what we would want in terms of test scores. Okay, large standard deviation, it's large, there's a large spread happening. So there's a lot of variability, which we don't want when it comes to test scores. Okay, so we just answered that question. Would we want a small or large standard deviation in terms of test scores? Small. We would definitely want a small standard deviation because the scores are closest to the average, and that's what we want. Okay, small spread means very, very close together. Okay, so creating a normal curve. Okay, creating a normal curve. You first want to identify the average. Okay, so the mean in this first example, John usually scores an average of 82% on his math test. Well, that is our mean. Remember, X bar means mean. So that is going to lie right here in the middle. Okay, this is where our mean lies. That's what you start with. Okay, then it says the standard deviation is 5. Okay, well, we have to apply that. So what we do, one standard deviation, is we take our mean and we add 5 to it. So what's 82 plus 5? 87, but we also have to subtract 5 from it. Yeah. Okay, so one standard deviation away has a range from 77 to 87. Okay, so if you add to one side, you have to subtract to the other. So the first standard deviation, add 5, and then subtract 5. One standard deviation away from the mean holds 68% of the data. Okay, you guys will not need to know or memorize the percentages, but typically when we fill out the normal curve, you want to know what this means. Like, yes, you could fill out the normal curve, but when it comes to percentages, it makes more sense. Okay, so then if we move on to 2 standard deviations, which is this line and that line, we're adding 5 and subtracting 5 again. So what is 87 plus 5? What is it, Nick? 92. And what is 77 minus 5? 72. So the second standard deviation is between 72 and 92, which holds 95% of the data, so even more, right? Even more, yep. That is called, when we're finished, the empirical rule. Okay, it's a set standard. anytime we're talking about standard deviation. So it's 68, 95, and 99.7. That is the rule. That's where those percentages are coming from. Yep. This is here, it's just even more of the population you're measuring in between 72 to 92. So it's 95% of the data is between this range. Okay. Then if we move to 3 standard deviations away, oops, we do the same thing. Okay, so 92 plus 5, 97, and 72 minus 5. 67. It's okay. Okay, so 67 to 97 holds 99.7%, which is the majority of your data. Will be within that range. Okay. However, a normal curve, this is as far as you go. 3 standard deviations above, 3 standard deviations below. The normal curve holds 100% of data. Okay. So, can people score less than 67? Or can John score less than 67? It's going to be a very small percentage. 0.15% would be here. Can he score above a 97? The percentage is 0.15. How did I get that? Because so far we're showing to the red is 99.7. So what's left to get to 100? Yep. 0.3. And if I divide that by 2, do I have 0.15 here? And 0.15 there? Yeah. That makes up a total of 100%. Okay. Where all your data should lie. Okay. But as far as we go, is 3 standard deviations above and below. Okay, so your job will be, can you fill out this curve based on information? Yeah. Do you need to put the percentages to it? No. Okay, so for number 2, you're looking at scores on the final exam in Miss Parker's Algebra 2 classes. You have an average of 88, standard deviations of 3. Create the normal curve. Go ahead. All right, so where do we start? Hannah? Which is? 88. Good. So the mean falls right in the middle. Then what is my range for the first standard deviation? Stefan? Good. Okay. How about the second standard deviation? Nick? Okay. And the third? No? Excellent. So that represents a normal curve. And remember, there's only 3 standard deviations above and 3 standard deviations below. There's no more than that. Okay? Questions? Let's move on. Okay, so we're going to look at this in our calculator, how the spread changes. Okay, so the first steps to do this in your calculator, enter data in L1, so list 1. Okay, once your data is in L1, second, what is it? Oh, stat, sorry. Stat calc, 1 var stat, and then enter, and you're looking for SX and the mean. Okay, so we're going to do a little recap, and you guys are going to try this. All right, so in your calculators, remember, if you have something in your list, we got to clear it out. Okay, hopefully everyone still has their L1. Okay, so you go to stat, Number 1 is edit, hit enter. You should have L1 to L5. If you have something in your L1, highlight L1, clear, then enter. Okay? If you don't, we're good to go. So enter data set A. We have 1, 3, 5. These are short, 14 and 17. Okay? Before we move on, data set A, B, or C, which one is going to have the smallest standard deviation? Smallest spread? Yeah. Set C. Okay, what's going to come next? What do we think? Mia? Set B and then set A. All right, let's prove it. So once your data is in there, you go to Stat, 1 over to Calc, 1 var statistics, hit enter. And then for mine, it's enter 3 times until calculate. So our mean is 8. Okay, our standard deviation is 7.07. They want you to run to the hundredths. Okay, so SX, this is our standard deviation. Right now, it looks very spread out, right? Because our standard deviation is so large. So jot that down. Now we're going to enter in data set B. Edit. Highlight L1 and clear, then enter. And enter in data set B. Oops. Okay. Our standard deviation is 2.74. Okay. Our mean is the same. So it was right saying that A is the largest standard deviation, B second, and now see what happens with data set C. So here the average again was the same, 8. Standard deviation was 0 because there's no change, no variability. Okay, so what can we conclude? What's the deal with data set A? Mia?
It had like the most spread.
Had the most spread. What is the range for data set A? 16. And our spread is 7, right? So there's a lot of variability with that one. Now, looking at data set B, what is our range? 7, our standard deviation is smaller because there's not a lot of variability. And 8, data set C, there's literally no change. Okay, it's all the same number, so there's no spread. There's no change, no movement whatsoever, so it's 0. Okay, you guys are going to try 2 on your own. All right, for number 1, where the examples are, the speed in miles per hour of Will's last 6 pitches. Okay, you're going to find out the mean and standard deviation. And then number 2 is the science grades. All right, take about 2 minutes to do that, then we will come back together. All right, so for number 1, what was the mean? Okay, at the bottom, what was the mean? Tate, what did you get? 75. Okay, what was the standard deviation? Camilla? 5. It says to the tenth, so 3.5. What was after? Was it 3.5?
Yeah.
Okay. So now, looking at this, our average was 75. Standard deviation is 3.5. Is there a lot of variability here? No, right? Do we see any apparent outliers? Not really, right? Okay, they're all roughly in the same ballpark. One could argue that maybe 71, 72, they're all kind of the same, all right? There's not too much change. However, in number 2, What is our average? What is our mean? Go ahead, Mia. 84. However, what's our standard deviation? L? 15.5, which is a large standard deviation. Do we know why? 52 is the outlier to make the spread very large, okay? But there's also a lot of variability of 52, 74, 80. You have some 90s in there, so there's a lot of inconsistencies. Yeah. So for standard deviation, the smaller one, right, for 3.5, it does have a small standard deviation because there's not a lot of variability, okay? There's not a lot of changes happening. There's no apparent outliers. That's how you could explain it in terms of spread and standard deviation. As opposed to this one, we have a larger spread because there are some outliers and a lot of variability happening here. Makes sense. So those are some keywords, and that's great that you mentioned. Variability, spread should always be mentioned when you're talking about standard deviation. Okay, makes sense? Okay. So we're getting into more visual representations of data. The next one is our histogram. You guys have seen histograms before, I would imagine, I hope. Okay, we will not be creating them. However, we have to interpret them, okay? So typically paired with a histogram, some cases, there's a frequency table, which you see to the right, okay? They already give you the ranges, okay? So for example, 41 to 50, 51 to 60, if you notice there's no overlap with these ranges, all right? So we want to fill out, we have test scores on the x-axis and the number of students on the y. So we want to take this data and create a frequency table. So how many students scored between 41 and 50? 3. Good. How many students scored between 51 and 60? Good. How many students scored 61 to 70? 10. Good. 71 to 80? 12. 81 to 90? Good. 91 to 100? 2. Good. So in total, how many students were surveyed? 40. Good. Okay, so in total, 40 students. So we create a frequency table based on the histogram. Okay, now we have some questions to answer. How many students got between a 61 and 90? How many students got between a 61 and 90? Kennedy? 30. So 61 to 90, you are adding those three numbers together. So 10 plus 12 plus 8 gives you a total of 30 students. Okay. How many students got lower than a 61? Ava? 8. So we have these guys here, which would be 8 students. Excellent. Can we tell how many students got a 76? No, Porter, why not? Right, we don't know the data, we just know the ranges, right? We could say, well, there were 12 students that got between a 71 and 80, but we don't know score specific because we're not given all of the data, okay? So you guys create that. We're given the ranges, not specific data, okay? So this is a big component, okay? Analyzing shape, okay? Anytime we're talking about shape, we're looking for a few things, okay? Number one, this first graph is symmetrical, okay? So it is a normal curve, okay? If it is symmetrical, so that's one shape that we're looking for. If it is symmetrical, the mean pretty much equals the median, okay? And we say this is approximately normal, okay? And it's always an approximation when we get to this, okay? So one way to describe shape is it's symmetrical, meaning the mean and median are roughly the same, okay? Calling it approximately normal. However, we will see some distributions where it looks a little different, okay? That is called skewness, where it's not symmetrical, okay? The biggest mistake that I have seen to determine if it's skewed right or skewed left, people tend to look at where the majority of data is. That is false. You're looking to see where the tail ends up, okay? So as the stairs go down and filter out, okay? So if it is skewed right, the mean is typically greater than the median, okay? If it is skewed right. So you're looking to see if the tail is to the right, okay? You're not looking at where the majority of data is. You're looking to see where the tail fans out, okay? If it is skewed to the left, you're going to see the tail on the left-hand side. However, the mean is less than the median, because remember, the median is the center of the data, okay? So we might have a larger outlier, greater outlier, that's bringing the mean and skewing it to the right. We might have a smaller outlier, but extreme, that is bringing the mean less than the median, okay? So, looking at this next graph, analyzing a histogram, looking at it, what would we say? Hannah? It is skewed right, okay? This is skewed right, because if you notice, the stairs are going down, okay? And the tail is longer to the right. So if it's skewed to the right, what's the deal with the mean and median? Hannah? Yeah. Okay. So skewness is important in terms of, we see it a lot with histograms, okay? So looking at A, B, and C, I want you to tell me if it's symmetrical, skewed left, skewed right, and then tell me what's happening with the mean and median. Go ahead. All right, so let's go through this. For A, Anthony, what's happening? Skewed right. So what's the deal with the mean and median? Good. For B, Kennedy, what's happening? It's symmetrical. That's what determines the shape. And the deal with mean and median. Yeah. Okay. Christopher, C. Skewed left. And what's the deal? Good. Perfect. The mean is less than the median. Okay, so this is important when you see either a graph, but you could also tell if you enter data into your list, okay, with the calculator, if the mean and median are different, you could determine if it's skewed left, skewed right, just based off of that, okay? The next visual representation, which a lot of you have seen, is a dot plot, okay? So this is what a dot plot looks like. This is minutes to eat breakfast and how many people are in each, like 0 minutes. How many people don't eat breakfast? 1 minute. so on and so forth. So what is the most frequent amount of time people eat breakfast? Hannah? 10 minutes. It has the most dots. What is the range in times for people to eat breakfast? Stefan? Careful. Yeah. 0, which the range is 12 minutes. But that's the range of data. You have to include it. Okay? How many people took 8 minutes to eat breakfast? Yeah. 2 people. Good. Now the same with the dot plot, it's very similar to a histogram. Okay? In terms of symmetrical, skewed right, skewed left. It's pretty much the same. Okay? This graph up here is one that we won't see too much. That is bimodal, which you wouldn't see. You guys wouldn't need to know the name of that shape. You just would need to know normal, skewed left, skewed right. Okay? Which again, doesn't it look very similar to a histogram? Yeah. The only difference is, are we giving ranges at the bottom? No. We're giving specific numbers. Okay? How many of you remember these? Box plots, box and whisker, kind of, sort of. Okay, so we are getting into the nitty-gritty of what is given to us in a box and whisker. Okay, the box and whisker is displayed in 4 even parts, not necessarily even to the eye. So this middle, if you notice, it's not really even, right? However, the percentages will not change, okay? So for a box and whisker, it's split up into 4 even parts. However, there's 5 numbers that make up that histogram. I mean, the box and whisker, sorry. So the lower extreme, called the minimum, is the lowest number in your data set, okay? Then something's new to you guys, okay? Something called the first quartile or the lowest quartile. Quartile 1, this is what it's denoted as, quartile 1. There's 25% of the data. So where this first line is quartile 1. So the percentage between the min and quartile 1 is 25% of the data, no matter the length of this, okay? The second quartile, we literally just call it the median, okay? So from the median, here's the median. From quartile 1 to the median, this little box here is also 25%. So if we split the median to the min is 50% of the data, okay? The next thing is quartile 3. We look at it as Q3 is another 25%. So this line here is quartile 3. And from the median to quartile 3 is 25% of the data. Then we have the upper extreme called the maximum. Okay? Here's our max. And from quartile 3 to the max is another 25%. Okay, so that's where it's split into 4 even parts. However, these guys here is called the 5-number summary, which I don't know if you guys realized, when we looked for the median at day 1 of this unit, the 5 numbers were given to you in the calculator. Okay, so there's another part regarding spread. You're looking at the middle 50%, which is called the interquartile range. Okay, the interquartile range is Q3 minus Q1. Okay, the interquartile range shows how spread out the middle 50% is. okay? When there is an outlier, okay, of any sort of which way, if there are outliers present, we use the median and the interquartile range as opposed to the mean and standard deviation. So if there are outliers, we use the median and the interquartile range to describe the spread. Okay? If there are no outliers, the mean and standard deviation would be used more so. Okay? So keep that in mind. So we're going to check this out in our calculator. Okay? We are going to enter the number of calories in each sandwich listed on the menu of a fast food restaurant. So in your calculators, go to Stat Edit and enter that data. Do what we normally do. Okay. So we should have all of our data in. Okay. Then go to Stat, went over to Calc, one var statistics. Calculate. You have your average, which is 371.6. It doesn't ask for that. The box and whisker does not show the mean. Okay. If you scroll down, this is your 5-number summary. 270. Quartile 1, which is also called the lower quartile, is 315. The median is 340. Quartile 3, which is the upper quartile, is 430, and the max is 580. So jot that down here. So we have 270, 315, 340, 430, and 580. And make yourself a note that this is quartile 3, that is quartile 1. Okay, so how do we graph these things? Well, anytime you graph a box and whisker, it's always above or below the line, not on it. Okay, so the scale is totally up to you. Okay, when you're creating these box and whiskers, okay, you want to make sure your increments are the same. So I believe I started with, I started at 250, then went up by 50. But again, you guys could do whatever you want. I skipped one in between. Okay. So now I'm going to plot this graph. So 270, and again, this is all approximation. Right there is our minimum. Lower quartile is 315. The median is 340. Upper quartile is 430. And the maximum is 580. I've seen many times that people want to just write on the scale these 5 numbers. That's not going to cut it. Okay? Your increments have to be the same. Okay? So looking at this, your first instinct, would this be normal, skewed left, or skewed right? What do you think? Yep. Okay. Yeah. Okay. What's the difference between the two? When you have something skewed right, no, I'm just I'm not saying who's right yet. When something is skewed right, what do you notice? Yep. Okay. How about mean and median? Okay, if it's skewed right, the mean is greater than the median. If it's skewed left, the mean is less than the median. I just want to show you. Our median was 340. Our mean was 371, right? So this graph would be skewed to the right, okay? Because the mean, so you were right, Hannah, the mean is greater than the median. The mean is greater than the median. And if you look at the graph, from this point, from the median, is this a longer side? Yeah. Okay, yeah. You're correct. You're correct. Just by looking at it, you go from the median. And where there's a longer side, is it if it's going to be skewed right or skewed left? All right? Try number 4. Hannah, question? I just looking at my range of numbers. Okay. This is what you should have gotten for your 5-number summary. Okay. 63 is the minimum. 71 is quartile 1. The median is 74. Quartile 3 is 79. And the max is 84. Okay. So we have, how many of you did get that? Good. 63, 71, 74, 79, and 84. Okay, it depends how you want to scale this. I think I started at 60, 65. Okay, and again, you could have a different scale than I do. So 63, 71. And again, sometimes when you draw these graphs, okay, sometimes when you draw the graphs, it might look symmetric to the eye. However, look at the data. So the median was 74. What was the mean? Kennedy? 74 as well. So when they're equal, this graph is what? Symmetrical. Okay, but doesn't it look a little different to the eye? It's based on the scale. Okay, looking at the scale. But we always go from the median to see the data, but always refer to the data given to you in the 5-number summary, as well as the mean. Okay? Any questions? Okay. So, looking at the double box and whisker, okay, we're almost done. The double box and whisker, you have Carl's and Angela's box and whisker plots in terms of sales. Okay? So, and everything is an approximation because, you know, it's sometimes hard to see. All right? So what is the approximate median of Angela's sales? Okay, so if I was to, for Angela's sales, draw somewhat of a line down, what do we think? 28, and again, anytime you say approximation, use those squiggly things. But 28, if you said 25, again, approximation, you're still in that ballpark. Draw lines to help you. What is the approximate maximum of Carl's sales? Hannah? 60. Let's see. Carl's sales. It's a little more than that. Yeah. 61, 62, in that ballpark. Which salesperson has the smaller median? Mia? Angela, good. Okay, some true or false statements. 25% of Carl's sales were between approximately 15,000 and 32,000. Kennedy? True. Okay, because 15,000 is about here to 32,000. So from quartile 1 to the median is 25%. Okay, true or false? 75% of Angela's sales were between approximately 18,000 and 58,000. Yep, true. This is also true because 18,000 is quartile 1 to the maximum of 58,000. Remember, 25, 25, and 25, making it 75%. Okay? Yeah. You're adding all those percentages. So quartile 1, you look at the totals, right? So quartile 1 is 18,000, right? The median was about 28. Quartile 3 is about 42, but the maximum is roughly 58. So then you add all those up, okay? So this is, again, analyzing distributions of a box plot if you want to refer back to. Normal, if you look at the center, it's always going from the median, which we talked about, okay? Now we want to interpret, okay? You guys are going to be interpreting these. Let me give you the scores because they're kind of shifted over, okay? The 5-number summary. This is 38, 72, 88, 96, and 102, okay? We'll get to those in 1 second, 1 through 5. And now 6 through 9, this is 0, 20, 48, 60, and then 190, okay? So what I want you to do is work through 1 through 9, okay? You may work with a partner, okay? You may work with a partner. 1 through 9, we should be able to go through these by the end of class, okay? Go ahead, you guys. Through 1 through 6, 1 through 5, and then 6 through 9, okay? Number 1, the highest score on the test, good, was 102, all right? What percent of the class scored above a 72 is 75% because it's quartile 1 to the max. What percent of the class scored between 88 and 96? 25%, so that's the median to quartile 3, good. Do you think this test was too hard? What do we think? Some people said yes. Yeah. Good. Okay. So this was not a hard test because 75% got a 72 or better and 50% got 88 or better. Okay. So this was not a hard test according to that data. What do you expect the mean to be above or below? Okay. So the median is greater than the mean. Why? So if I wrote it another way, why is this the case? Which is the same thing as what you see here. Yeah. It's skewed left, and we have that outlier of 38. Okay. How many of you did get 1 through 5? Correct. Okay. Then we have 6 through 9. Okay. Average minutes per night spent on homework. Okay. What percent of sophomores spend more than 60% on homework per night? It's 25%. The interquartile range is the middle 50. So it's quartile 1 to quartile 3. So it's 20 to 60 or 40 minutes, okay, is the spread. Then for number 8, what percent of sophomores spend less than 20 minutes per night on homework? Emily? 25%. That's going to be your percentages, either 0, 25, 50, 75, or 100. It won't be 10%. Okay, so 25%. And number 9, would you expect the mean number of minutes be higher or lower? It would be higher because it is skewed to the right and we have that outlier of 190. Okay, how many of you did get this correct? Excellent, you guys. So even though you know the information, it's interpreting is where it's going to come into play. All right. Your homework is as follows in the pink packet. 4.1 practice, page 3, 15, 21, and 22. I think 21 we might have had or may not. I don't know. So 4.2 practice on page 4, 1, 2, and 3A. 3A is just filling out the normal curve. Then page 5 and page 6. Let me fix that for you.